What is up, Flutter devs? Today we're going to build a very simple version of the traditional snake game using Flutter processing. This is based on coding challenge number 3, I think, from the coding train. Let's go figure it out. First, let's make sure we all agree on what we're building. We're building something similar to what you see here. This green thing we're considering to be a snake, and one of these ends is the head of the snake. I'm not sure which is which in this screenshot because we can't see it moving. But the head is constantly moving forward, and the player can change direction of the head to go left or right from the head's current perspective. So let's say this thing right here is the head. We're going to keep moving to the left unless the user presses the up key, in which case we go up, which is the head turning to the right, or the user presses down, which is the head turning left, going down from our perspective. But the snake is always moving. And every time that the head moves 1 unit forward, the tail kind of contracts by 1 to give you the appearance that the snake is slithering. Now, when the head overlaps a piece of food, 1 additional unit gets added to the end of the tail of the snake. And the snake is never allowed to run into the edge. The head is not allowed to run into the edge of the boundary, and the snake is not allowed to run into itself. If either of those things happen, it's game over. So we're going to build this today using Flutter processing. Let me start the app launching here, and then let's talk about what we need to do. The very first thing that we need to create here is actually similar. It's the same kind of steps that we took in the previous video with Conway's Game of Life. We need a grid. A grid means a certain number of columns, a certain number of rows, certain number of pixels per cell. Let's get that set up while this thing is launching. So let's say that pixels per cell is 10. And then eventually we're going to calculate a column count and a row count. And we are going to have a condition that says, is game over? That's going to be false. We're not going to get to game over conditions for a little while probably, but eventually we're going to need to mark the game as being over because we ran into the side or we ran into ourselves, the snake. Within setup, let's use a width and a height of 500. And so if we think about that width and height divided by 10 pixels per cell, we're looking at 50 cells, both horizontally and vertically. All right, and now this thing is launching. All right, and then we're going to open up the snake game. We haven't saved this new size yet, so it's still tiny. Now let's also adjust the frame rate. So when this snake is moving, if it's moving 60 times per second, it's going to be all but impossible to play the game. This is more of an old school arcade style game where it was just a few game frames per second. We're going to say that the frame rate is equal to 10 frames per second. You can adjust that up or down, but that's going to be a lot better for us than 60 frames per second. Now let's calculate the number of columns. That's equal to the width divided by pixels per cell, and we're going pixels per cell, and then we're going to floor that. And then row count is equal to height divided by pixels per cell, and then we're going to floor that. Once again, similar to the last video, we're operating with square cells. And then in a minute, we're going to need to actually create the snake. We'll create that as an object. But before we do that, let's also fill the background here. And I think I was matching Dan's work on the coding train. So let's say color from ARGB. I think this is what he used, which was the 51, 51, 51 gray color. And then, of course, we need to implement everything there in the draw. Here, we still need to create the snake at a random position. Let's save that. Okay, now we've got our 500 by 500 sketch canvas, and the background color is this kind of like a fifth gray, so a dark gray. And then on top of this, we want to draw a snake that slithers that we can control and draw a piece of food randomly. Let's figure out how we're going to do that. Let's start by creating an object for our class for the snake. Now, what does this snake do in turn? Like, what information do we need to track in here for the snake, and how is it going to change? Let's go back to the game with the screenshot. The snake is comprised of a series of cells. At the beginning is the head, at the end is the tail, and then every cell in between should be connected to every other. We don't need to carefully enforce that. We just need to make sure that the head only moves in ways it's allowed to, and then we will only ever accumulate cells that are connected. But we do need all of those cells. We need to know what to draw for the snake. This means that we're going to need a list of points of integers. We will call it cells. And we'll make that private in terms of being able to change it, but we will allow others to get that list of cells for painting. Now let me go import math. Okay. And let's create the constructor. We're going to take in a random point to begin. It doesn't have to be random, but it will be. We're going to take in a single position, and then cells is going to be equal to a new list with just that one position. The snake is going to initially be just one cell long. What we can do is now come up here. Let's create a place for the snake. And right here we will say snake equals snake position. And we're going to say, let's create a method to get random cell, because I think we're going to use that later. We'll return a position with an integer, say get random cell, and we will say random equals random, and then we're going to return, not position, point. We will say random get, or so next int, and let's see, what's the maximum here? The maximum would then be, for the x value, is the number of columns. And then we want random next int row count to get a random y value. That gets us a random cell, and we will start the snake at a random cell. This now allows us to at least start drawing the snake, even though for now the snake is just one cell. To do that, we will say the fill color is white. So we're going to draw white cells. And then we're going to say for cell in snake.cells, we're going to fill a rectangle from left, top, width, and height. So what is the left and the top? Well, that's the X and Y position of the cell. So we're going to say cell X. Now cell.x is the column number. So it's 0, 1, 2, 3. We need to multiply that by pixels per cell. Same thing with top. We'll say cell.y, but then we need to multiply that by pixels per cell. And then the width is pixels per cell, and the height is pixels per cell. Save that. And notice right down here we have a one cell snake. And every time we recreate the game, it's in a different position. Okay, that's one step done. Now there are a number of things we can tackle next. There is motion, there is keyboard control, there is generating food. I guess probably motion is the thing that makes the most sense to do next. So let's say update the game loop, and what we're going to call there is snake.update. So the snake, in this update method, the snake will move itself in some direction. And this means that the snake needs to have a direction. And to have a direction, we need the concept of a direction. Now you could store this as a vector or something, but I'm going to create an enumeration called direction. We're going to say left, up, right, down. But not only do we want the concept of a direction, there are a couple behaviors that I would like every direction to have. See, when the snake is moving and the user presses up, down, left, or right, we can only honor that when the user is changing the snake's direction to the left or the right from the perspective of the head. The direction of the snake can't change in any fashion whenever it wants. It's limited based on the current direction. Also, when we move the head, it'd be nice if we could just say, here's the current direction of the head, give me the next cell. So let's add some extension methods on this. Let's say extension on direction to give this enum some behaviors. And we'll say, first we'll have this method called isOpposite. We're going to see if a given direction is the opposite of the current direction. We're going to say switch this. So we're going to switch on our enum. Given these directions, if we are the left direction, then we want to know if this other direction is the opposite of left. Well, what's the opposite of left? The opposite of left would be other equals direction.right. And the opposite of up is down. The opposite of right is left. And the opposite of down is up. This is a tool that's going to make our decision around keyboard handling a little bit easier so we don't have to keep implementing the answer to this question. The second behavior that I want is I want to be able to take a point, a position, and I want to be able to move it in the direction of this current direction. So whatever direction we are, I want to move this position. Once again, we'll say switch on this. We'll generate all of the clauses or all of the cases. And then for left, we will return position plus -1 for the X. For up, we will return -1 in the Y direction. For right, we will return +1 in the X direction. And then finally, for down, we will return +1 in the Y direction. Okay, again, these are tools that will make our job easier when we're moving, updating the snake and whatnot. Now, the snake, I said it actually needs to have a direction, right? So there's going to be a direction here. We'll make it private. We want to change the direction. We don't want other people to change it. For simplicity, we're always going to default to moving right. Now that's not great because if the snake appears too close to the right side of the screen, you're going to die immediately. But these are things that you can figure out if you want to add some more complexity to make the experience better. We're just here to look at fundamentally how to build this thing. Now I guess I was wrong in what I said before. We do want the outside world to be able to change the direction, but we want to add a rule to that. We don't want to accept any direction. So only if the new direction is not the opposite of our current direction do we want to make this change. So already we're using the tool that I mentioned. If the snake is moving to the left, we don't want the user to be able to invert the direction and go back to the right. Because for a snake that's more than one cell in length, that would mean the head of the snake starts eating the body of the snake, and that doesn't make any sense. So we're not going to allow the direction to invert itself. It can either go to the left, it can go to the right, or if this is the same direction we already have, then it makes no difference, so we don't really care. That's the direction, and now we need to update. We need the update method. Here we're going to use the second tool that we created. We have an existing position for the head. We need to get the new position based on the direction. So the new head is going to be equal to our direction.move, and we need to access the current head. Now, where does the current head come from? Well, the head is always the very first cell in our list, right? So what we can say is point int get head is cells.first. The head property is always the very first cell. So we can take that head cell, take the current direction of the snake, move the head based on that direction, and now we get a new position for the head. Here we need to say, check if snake just ate food. We're not there yet. And then we need to say, to actually move the head, we need to say cells insert 0 new head. But this is still a little wrong because this will actually grow the snake by 1 cell every time. We don't have the eating logic here yet. So until we have the eating logic, what we're going to say is cells remove last. We're going to take 1 off the end, and then we're going to add 1 to the beginning. When it's just 1 cell, we're emptying the list and putting it back in. But when there's more than 1 cell in the snake, we're taking 1 off the tail, we're adding 1 to the head, and that adds the appearance of slithering around. Now, when we bring the food into this, the reason I put this to do here is because when we eat a piece of food, we don't want to remove the last cell because we want to grow by 1. Only when we eat the food, though. Now, I think if we run this, we're going to have a snake automatically moving to the right. So let's see. There it goes. Now, it can run into the side. The game doesn't end because we're not checking for an end game position, and we don't have keyboard support yet, so we can't change the direction. And you can see how when it starts too close to the right side of the screen, the user's in trouble. But we're just going to put up with that. Let's go ahead and add the keyboard support. Here in our sketch, we will say key pressed. And if key is logical, keyboard key, arrow up, we're going to do something. And then else, if it's arrow down, we're going to do something. Or if it's arrow left, or if it's arrow right. Here we're going to say snake direction equals direction dot up. Now we can do this mindlessly because we know that our direction setter will not allow us to invert the direction. That was the benefit of centralizing it. We don't need to keep asking, is this the opposite? Is this the opposite? We won't be allowed to change it to the opposite. Now let's see if that happens to work here. I think what we have here is, so I'm pressing the keys, and sometimes it works and sometimes it doesn't. I think the problem that we have here is a focus problem. I think focus is being given to a different area of the Flutter UI. So let me go add some, I should probably move this somewhere deeper into the processing widget. But for now, we'll just have to implement this here. I'm going to create a sketch focus node, a focus node that we're going to apply to the sketch. And every time that we reassemble, so every time that we hot restart, I'm going to force the focus back to that node. We want the sketch to always have focus so that whenever I press keyboard keys, we're capturing those keys. Now down here in this demo, sketch focus node, we're going to pass in the sketch focus node. And hopefully also whenever we restart the game, we get focus back. Let's see if that makes a difference. Okay, now I've got control. So there might still be some edge cases where we lose focus, but once I've got focus in here, I can use the arrow keys here to change the direction. And I can verify that when I'm going up, I can't press down. When I'm going left, I can't press right. So I can only change the direction of this thing. I can only change the head direction left or right in the direction of motion. Okay. Well, now this also opens up the ability for us to create the end game, one of the end game conditions. If this snake goes off the screen, then we'd like for the game to be over. We can do that check, I think, in the draw method. We can check for game over condition. If the snake is not in bounds, and we're going to give column count for the width, row count for the height. Now, this is not the only game over condition. This is the one where we run into the boundary. Then there's the one where the snake runs into itself. We need both of those, but this is the first one. Let's add this method to the snake. Let's have the snake be able to tell us whether or not it has run into a boundary or whether or not it's in bounds. We will say Boolean is in bounds. Width, int, height, and we will return head.x is greater than or equal to 0, and head.x is less than width, and head.y is greater than or equal to 0, and head.y is less than height. But also, what are we going to do when the game ends? The very first thing we're going to do in draw is we're going to say if is game over. We are going to set the background color to red. We're going to fill the screen with red. Then we're going to stop looping, and then we're going to stop drawing. So watch it hit the side. Boom, game over. And then we can restart. All right, let's hit the top. Restart. Let's hit the left. Okay, restart. Let's hit the bottom. All right, that game over condition looks good. How about generating food? If we're going to grow the snake, we need to generate food. Here you could have different timing logic in terms of when and even where you want to generate the food. We're going to take a very simple approach. Our approach is going to be that if there is no food, we'll generate food. And if there is food, we won't. We're going to have a variable I'm going to create in a moment called food. If that's null, then we're going to set it equal to a random cell, which means that food is going to be a point. It's going to be a point int that may not exist. There's food. And this is get random cell. But we also need to draw the food. We're going to draw the food before the snake so that when the snake hits the snake is over the food, above it, on top of it. If food is not equal to null, then we're going to set the fill color to red. Food is going to be red. Then we're going to create a rectangle. And we're going to say food.x times pixels per cell, food.y times pixels per cell. The width is then going to be pixels per cell, and the height is pixels per cell. And in our case here, what we are saying is that the food is going to be the size of a cell. You could also make it smaller than a cell if you want. That might make more sense, or maybe a little circle within a cell, whatever, your choice. Okay, and there's some food. Now, I'm not going to be able to actually hit this thing. I mean, I'll hit it, but nothing happens. We don't grow. So now when we get the food, we need to actually grow. After we draw the food, draw the snake, we're going to say eat maybe. So if food is not equal to null, we're going to calculate whether or not the snake just ate the food. we're going to say snake maybe eat food. So we're telling the snake, here's where the food is. If this is where your head is, you should eat the food. And then if did eat, we're going to set the food equal to null, which means we need this maybe eat method down on our snake. Maybe eat. We're going to take in the food position. And then we're going to, so remember down here I said we care about whether or not we just ate. We need to store in a variable did just eat equals food position. If the food position is same as head, then yes, we just ate, and we will return that value. But we need to remember that value for later. Down here in update, only if we did not just eat do we want to move the last cell. Otherwise, we want to grow by 1. But then after we eat, we need to set that back to false so that we don't keep growing forever. And now let's see where we are. Whoops, too close. Let's see if I can hit this thing. Oh, now we're 2. And I'm not very good at this. Now we're 3. Now we're 4. So we're growing, we're moving, slithering, we keep growing. And we've already tested the boundary condition. So we know that's going to work. The one condition, the one thing we have left for this game at this point is that when the snake wraps around itself, when the head runs into a later part of the snake, we need to end the game. So for example, I'm not even sure if I can do this if I try. That probably should have ended right there. So we need to check if the snake intersects itself. Let's go back to the game condition here. Where was that? Check for the game over condition. We need to say, so if we run into the boundary or the snake is overlapping, which means we need to implement a method that checks if the snake is overlapping. Is overlapping. What do we need to do there? Well, this first part, I'm going to do a little optimization, not really necessary, but if you think about it, it's impossible for the snake to overlap itself if it's shorter than 5 cells. Because 4 cells, no matter how you orient yourself, the tail is always going to move out of the way before the head can hit it. So we can short circuit and say if cells.length is less than 5, then we can return false. Again, really doesn't make a difference, but it's technically true. But then we're going to say for I is 1. Why are we starting at 1? Because the head is at 0. The head can't intersect itself. If cells I equals head, then we return true. We have intersected ourselves. We've run into ourselves. If we get to the end of that loop and nothing happens, then we return false. We are not overlapping. So let me slow this down a little bit so I can more easily hit the food. Let's see, what is this complaining about? Yeah, it is. Let's see what am I missing here? Is overlapping. Oh, okay. That doesn't need to be, that can be a get. So, okay. Let me slow this down a little bit so I can more easily grow the snake and prove that we end the game when it hits itself. Is there still a problem here? Okay. This is going to take a little while. All right. Now that's 4. 5, we could, I think, technically run into ourselves, but it would be kind of tough. So let's grow a little bit more than that. Another way to make this faster would be to have more pixels per cell. Well, I thought I ran into myself there, but it didn't trigger. Okay, that time it triggered. So I think we're good. And I think with that, we now have the snake game. And I can put the frame rate, I guess, back up to where it was. Or if you want it to be really difficult, you want to go full frame rate. Uh-oh. Ah. That's way too hard. Let's go back to 10. And let's pump up the grid a little bit. Let's go 20 pixels per cell. And now I'm kind of just playing the game. So I guess technically the exercise is over. That's going to be a hard one to get. By the way, you might want to limit where the food can appear, because that's pretty tough. Uh-oh. That looked wrong. What caused that to break? I don't know how I broke it there. Well, I'll play around with this a little bit longer and see if I can find what may have gone wrong there. And if I can, I'll put up the code with the fix. But maybe it'll take one of you to figure out if there's a bug somewhere in that end game logic. But all right, that is coding challenge number 3 from the coding train, as we continue to stress test our Flutter processing package. And I will see you in the next video.